What's good, everybody, and welcome back. You're watching the second part of this series where we go through the managed container objectives for the RHCSA. Feel free to check out my previous video if you haven't already done so. In that one, we covered these first two objectives, and actually a good portion of this third one as well. This video will definitely fill in any gaps as we'll be covering most of the remaining objectives. I'm just going to leave out the one about container files and systemd services, as I want to save those for the third part. Anyways, let's get started with this one about running, starting, stopping, and listing containers. So I'll just bring up my terminal again. There we go. And we'll jump into listing containers first. Now, if I run podman ps, this will print out a list of the running containers. And as you can see, there aren't any currently running. If I were to run podman ps -all, or just -a for short, this would list all of the containers regardless of whether they're running or not. Of course, we still won't see anything particularly interesting yet. So let's take a look at the images that we can make a container out of. So running podman images will show us the images we pulled in the previous video. And right here, I want to point out this UBI minimal image. So like I mentioned last time, this stands for the universal base image. And as the name suggests, it's basically a generic image that works and acts like a stripped-down version of RHEL, and it's used for building more specialized images like HTTPD, for example. So for simplicity, let's start with that one. We can initialize a container from this image by running podman run, and then providing the image's name or its ID. So I'll just give the ID. And check this out. So when I run this command, it takes a moment, and nothing seems to change. And if I check podman ps, we can't see any containers running either. However, podman ps-a will give us a better clue of what's going on. As you can see, the container we just made exited almost immediately. And so here's why that happened. By running podman inspect on our image and grepping for the initial command like this, we'll see right here that this image wants to run bin bash by default. As many of you already know, bash is an interactive application and it expects a TTY to attach to and an input stream to read from normally. So when we ran our container, bash didn't have much work to do, so it just quit. Since it was the initial and only process we had in our container, the entire container exits. Anyways, going back to podman ps-a, another thing I want to point out is that this container still exists on our storage even though it exited. That's the default behavior of podman, and we can override this if we wanted to. This command also shows us that our container was assigned a randomly generated friendly name right here, and this is because we didn't specify one. Anyways, we can go ahead and remove this container with podman rm and then provide the ID or the friendly name. So I'll just give the friendly name. And there we go, now it's removed. If you wanted to remove all of the exited containers, then you could run podman rm-a, and this would remove all of them. Since I removed the one and only container we had, this command isn't going to do much, but of course be careful when running that, or you could blow away something important that you've been working on. Anyways, let's go ahead and spice things up. This time, we will initialize a new UBI container with some additional options, so we can actually make some use of it. I'm just going to pull up my images with podman images, so I can check the ID that I need. And then we'll just enter in podman run-i-t, or just IT for short, where I stands for interactive and T stands for TTY. And this will help us out since we want to run bash. We can also give a name to our container with --name, and I'll just call this one myUBI1. And next we specify the image that we want, so I'll just give this image. And you can also give the address name if you want it as well, but this just works fine. And then at the end of the command, we can specify what initial program we want the container to run. So I could just put in bin bash right here, but this is going to be redundant since we already know this image is set up to run bin bash by default. And now by running this command, we can have an interactive shell session in our new container. So this UBI minimal image comes with the standard set of GNU core utils, so you can just start writing and running little scripts in here right from the get-go, like grep or cat, all that good stuff. And there's also micro DNF, which is like DNF or Yum except simplified. So this is the way that you would install your packages, as you might have guessed. So I could do something like grab microdnf install proc psng, and this will install the ps command. So now I can run ps-ax, and look at that. We can only view the processes in this container because it's a container, and that's what containers do. Pretty cool. And just to be clear, these qualities apply to the UBI minimal image. There's also a UBI standard image that comes with regular DNF, and another superset of that image that comes with systemd. There's also a micro image with no package manager at all. So you've got a lot of variety to choose from with UBI. Now let's say that we had our fun with our container, so we just exited out of bash, and we'll be dropped into our normal host shell again. And if I run podman ps-a, you'll see here that our container is exited. So if we ever wanted to get back into this container, we need to understand that bash and the container itself are no longer running. So we need to start them back up with podman start and then our container name. So that's my UBI1, and this will start it back up. And from there we can run podman exec-it and then the name of our container, my UBI1, and then the command we want to run inside of it again. So that will just be bin bash. And it's usually a good idea to provide the full path of the binary, but you don't have to. I'll just show you that in a second. And there we go, we're back in bash. So of course you can put in whatever command you want here. I could put in the echo command. And since echo isn't really interactive, we can remove these options and it'll work just fine. So that echo was running from within the container. So another important thing I want to show you is the -d flag for detach. This will make sure our process runs in the background. This is usually used to keep something running in the container so that it remains alive. So I'll start a new instance to demo this. So I'll just pull up my images again to check the ID. And then I'll just run podman run itd, and then I'll give a name like my UBI2, and then specify the image. And then I'll just, I don't need to run bash, I can just do this. And there we go. So now this container is running in the background. So if I check podman ps-a, you'll see here that it is indeed running, even though we're not directly attached to it. So it's just floating around, and I think that's pretty cool. Anyways, the commands podman start and podman stop will become clearer when we run a proper daemon like httpd. But just to give you a taste of what would happen, we can see both of our containers are running right now. And now let's try to stop one of them with podman stop my UBI1. And look at that. So it just hangs around, and eventually it's going to yell at us and say that it failed to signal the process. So we'll just cancel that, and instead we'll run podman kill my UBI1. And this will kill the process running in the container. So remember, this is equally as destructive as running kill-9 on any other process, but I believe the reason that we would need to do this is because bash in our container traps the sigterm signal, which is what podman stop uses. Anyways, we can start it back up with podman start my UBI1, but this creates the same problem again. So we can just kill all of our containers with podman kill-a. And lastly, we'll just rm the containers with podman rm-a. So that was a good segue into the next objective which we'll cover, which is running a service inside of a container. And we'll also lump this along with attaching persistent storage, since they kind of go hand in hand. So yeah, this will be a jam. So I'll head back to the terminal and just clear the screen. And then I'll run podman images once again. And so, I mean, this is going to be pretty easy, since we've already pulled an image that runs a service, and it's right here. It's UBI9 HTTPD. Don't worry though, if you're interested in more detail on this kind of thing, it's coming in part 3 when we write a container file to build a service hosting container ourselves. So anyways, the important part right now is just knowing how to allocate the right resources to make the containerized service useful. I'm talking about passing through ports and file system locations, things like that. We already know how to start a container, and in fact, if we do this on UBI HTTPD here, it'll just fire right up. So I can do podman run -it and then our image, and there we go. It's just running. But this isn't exactly ideal, so I'll just cancel out right now. And what we would really want it to do is just run in the background, so detached, that's pretty easy, and also able to listen on one of the ports of our host system so that it can communicate on our network. In this current configuration, it can't really do any of that stuff. So I'll just RM the container, and we'll pass these options instead. So I'll clear the screen, and looking at podman images one more time just to make sure, we'll run podman run, and then we'll pass a name this time, like my HTTPD1, that sounds good, and then a -d for detached, and then a -p for port, or actually I think it stands for publish, but you know, potato potato. What we really want to do is bind a port from our host system, like 4080, to a port on our guest. And if you remember from the last video, when we inspected this HTTPD service, on this image, it's set up to listen to 8080. So we'll just put that in there. And it's also worth mentioning that since these are rootless containers, don't try to open up any privileged ports because that's just going to be disallowed. So we can just run this now, after passing the image ID, of course. And now we're getting somewhere. So we aren't flooded with any of the standard output of HTTPD. And now if we try to curl the page running on our local host on 4080, we're getting some output. So that's a big booyah right there. It's clearly working. Let's get even fancier though. So we can make a permanent firewall D exception for 4080 like this. Sudo firewall cmd --permanent. I always have trouble spelling that. And then --add port 4080/TCP. Just like that. And enter your password, and there we go. Then we'll just reload the firewall configuration like this. Cool. And now we should be able to check out the test page from our browser on our workstation. So I'll just go over there to appserver4:4080. And there we go. We got the test page. So if you're wondering why we're getting the Red Hat test page even though we're on a Alma Linux host, that's because the container is running RHEL. So we're getting the Red Hat resource. Just in case that was a little bit confusing. So yeah, going back to the objectives, of course, the last thing I really wanted to show was attaching persistent storage. So this works a lot like the bind option in mount. In fact, it might actually be like that under the hood. I don't exactly know. So we'll go back to the terminal and I'll clear the screen. And now let's say that I had a folder called webdocs in my home directory, and I wanted that to be the document root of the web server. So I'll just make some test files real quick. Index.html. We'll just make it say hello. Just like that. Okay, cool. Now this will be pretty straightforward. Just as we were able to forward a port, we can also forward storage. So I'll just stop our old my HTTPD1 container so we can get that port back. And then we can make a my HTTPD2 container just like the previous one, except with an additional option, -v. So I'll pull up that old command, my HTTPD1, there we go. Cool. And we'll change this to number 2, and we'll add that new option. So -v, and we can give this our /home admin webdocs directory, and then put a colon, and then forward this to var www html in our container. And then remember to put this at the end, colon lowercase z. This is going to basically tell Podman to relabel the proper SE Linux type context on files in this directory so that they can be accessed by the containerized process. If you give an uppercase C, this should make it extra strict where the other containers running won't be able to access this volume directory, except for this instance. And just because I think you all are really cool, let me show you another nice trick. You can pass multiple volumes by just doing -v again. So you can pass discrete files or even socket devices like devlog, and then I'll just forward that to devlog in the guest. And we don't want to put a :z on this because we don't want to relabel a system file like devlog, of course. So now we'll just run this, and we're going to be back in business. If we check our browser, we'll see here that our index page has changed. Very nice. If we exec a bash session into our container with podman exec -it my httpd2 and then bash, there we go, we can run the logger command, which connects to the devlog socket. And so I can just say hello from Beanology, like that. And this will go and send it to the devlog on our host. So effectively, we can unify at least some of our logging using this cool trick. Now, HTTPD normally logs to its own file, but this is still extremely useful. And we can check our messages with journal ctl-f. And let's see here. There it is. Hello. Pretty cool. So yeah, another thing I would want to show you, let's clear the screen, is stopping the container. So if we run podman stop my httpd2, we can check on our browser, and as you can see, the page is no longer pulling up anymore. So we can neatly start it back up with podman start my httpd2, and let's see here. And the site is live again. Alright, so I think that about does it. We covered a ton of cool stuff. So I hope this video was useful for you. Stay tuned for part 3, and thanks for watching.